Welcome to our build series for our 4-inch scale Burrell DCC road locomotive traction engine kit by Steam Traction World of Daventry, England. This is supplied as a series of 30 fully machined kits to build a fully operational steam traction engine. Each kit includes all parts, hardware, detailed packing lists, assembly diagrams, and instructions. Kits arrive approximately one per month. Parts must then be cleaned, fitted, painted, and assembled using standard workshop hand tools and a few basic power tools. No machining on a lathe or mill are necessary. When complete, the engine will be 33 inches wide, 83 inches long, and 48 inches high with a weight of 1,650 pounds. The boiler is 10.5 inch diameter, built of welded steel boilerplate, and designed and tested for an operating pressure of 180 psi. If you're just joining us, note that tasks common to each kit are highlighted in video 1. These tasks are not demonstrated in this video with the exception of some additional scenes of lining parts. Additional videos in this series will appear but at no set time frame. If you choose to follow the series, videos will be released as a particular kit is fully, or at least substantially, completed. In this second installment, we will be constructing the front axle and perch assembly and test fitting the front wheels. To begin, we test fit all parts prior to painting to highlight any possible issues. The first one that was discovered was the mating of the pivot to the spring hanger. Our spring hanger would not fit within the pivot casting. After careful examination, we noted the sides of the spring hanger were not parallel. The ends that the pivot shaft passes through were spread further out than the area the leaf springs mate to. Our solution was to place the spring hanger in a bench vise with a spacer the same width as the springs placed between the hanger sides. The vise jaws were then slowly closed to compress the sides slightly beyond parallel. We were careful to place the part in the vise to be sure there was no significant force at the weld points between the top plate and each side plate. This was done several times, each time releasing the pressure to check the distance between the sides, then repeated with a bit more pressure until the sides were parallel. A check of the spring hanger width and the mating opening in the pivot casting showed the space in the casting was undersized compared to our spring hanger width. We started by rough grinding the casting in the area of the pivot hole to enlarge the width of the casting close to the width of the spring hanger. A grinding bit in a flexible rotary tool worked well for this task. Once the size was close, we finished by filing and sanding to a smooth surface. This process was repeated many times, removing a small amount of material each time. In this way, we could ensure that we did not remove too much material in one pass. The final result is a spring hanger that fit into the pivot casting with just enough clearance to allow it to pivot smoothly around the pivot shaft.
Dried paint.
Okay. Very close.
What?
Very close.
Good. You know, I was thinking, they've got those belt sanders.
Smooth. The spring hanger falls right through now. Before it wouldn't fit at all. And there we go. The spring hanger. The individual leaves of the leaf spring were assembled to the spring hanger with a long screw. the screw was tightened completely. For the test fitting, this screw was left long. Once the leaves were painted and lined, the screw was tightened one last time, then cut short to allow the assembly to fit into the pivot casting without the screw interfering with the casting. None of these parts have been touched yet, so we'll see if there's anything that needs adjusting or if they just need cleaning. Okay. The two spring pads were fastened to the axle prior to assembling the spring assembly, axle, and perch together. I'm not going to tighten these down for now. Okay. To assemble the spring assembly and axle together, it is necessary to slightly compress the spring. For test fitting, this was done by aligning the pivot and one side of the spring hanger holes and using the pivot pin to secure them in place. Two opposing tapered wooden construction shims were forced between the axle bottom and the bottom inner surface of the pivot casting. We realized this would never work once the parts were painted. For final assembly, we used some large bar clamps to help compress the leaf spring enough to align all the pivot holes. The pivot pin, a washer, and split pin are used to secure the assembly together. These parts should pivot smoothly, but without any significant side play. The smoke box saddle drops on top of the pivot casting. A flanged retaining collar is placed over the protruding top of the pivot casting. A pin passes through both parts to secure the smoke box saddle casting in place. To secure the pin, two split pins are used. Because the axle will need to be removed during further assembly, I opted to install one split pin to the securing pin. When temporarily assembled, a wire bread tie is passed through the other end of the securing pin to keep it from sliding out. This will be replaced with the remaining split pin upon final assembly. The axle had machined surfaces, but some non-critical areas were still quite rough. We carefully ground and smoothed these surfaces to blend into the machined surfaces. We made certain not to disturb the factory machined surfaces.
closing this door? It's a force of habit, a simple precaution when I have a valuable diamond out of the safe. That's quite admirable. Don't you think so, Lauber? Ja, mein Herr. You understand? You're trembling, Van Linden. When you stand so close, diamond cutters are like brain surgeons, Lauber. Quite you the stone. Who will cut the Regency? Van
Steve?
Linden's replacement.
Yeah? Come here.
You have found such a man? Yes.
You don't
The
sound
greatest
happy.
diamond cutter in America, George.
Our designs for lining the various parts are based on common Burrell lining designs with inspiration from photos of two fully restored road locos. A combination of masking, hand lining, and a bugler striping tool will be used for these details. After careful consideration, we decided not to follow any one specific prototype for our engine's livery. During test fitting, we discovered our wheels did not sit down far enough on the axle ends to allow the retaining collars to line up with the holes on the axle. The retaining pins could not be inserted through the holes in the collar and through the axle end holes. The wheel hub bearings were fully seated in the hub, and the correct bearings were used in the correct positions when assembling the wheel. Our wheels appeared to fit fully down on the axle as far as they should, so I cannot explain our misalignment. Our solution was to use our hobby mill and mill the back surface of the retaining collar to reduce the thickness slightly on one side. A flat was also milled along the length of the retaining pin. The collar could then slide far enough onto the axle to align the respective holes. The flat on the pin allowed that to slide through the holes while clearing the outer surface of the hub. The front wheels are secured to the axle by placing a retaining collar over the end of the axle. A pin passes through the collar and axle, and the brass hubcap screws to the wheel hub. When the brass cap is installed, it traps the retaining pin and prevents it from falling out. The hubcaps were secured loosely with the supplied screws, and the front wheels spun on the axle for the first time. I'm sure the wheels will be removed many more times before our engine is finished. Be sure to join us next time when we will work at finishing and assembly of Kit 3, the smoke box.